Hello everybody, this is Ziyang Tang from BME 595 project. My project is image colorization, and now let me show you my code. First of all, I wrote a code of the data loader here and to load the images. So the data set is from 3 different places. The first data set is from ImageNet detection data set, so it contains about like 1 million training data, and another data set is from ImageNet video detection. So I'm doing the video because my thesis is doing the video colorization. So for this project, it's about some previous work of the image colorization. So it's the previous work for my thesis. And to show the demo, I just use a small data set of the BME face data set. This data set only contains about 100,000 training data, so the data set is really small, and we can see the results in very quick. First of all, I use a UNet-like architecture from the SIGGRAPH 2017 papers, and so this is basically how I define the generator and the discriminator. And then I also use the pixel-to-pixel models here, but the difference is that I only use the generator and I didn't activate the discriminator. So it's actually a classification problems here. For the results, I also have generate the regression results and the classification results, but I find that classification results is better. Okay, now let me show you how to train these models. First of all, I wrote a wisdom server to see the training process. So to run the model, you need to open the remote server first, and the code is python/m and wisdom.server. And as we can see, we can go to the website localhost 8097, and this is the default setting of the PyTorch. After that, we can train the model here. So I have already set up the parsers here. So just run the Python train.python, and then the dataset roots is for the dataset, like the train here, and then the image roots is training list, which contains all the passes of the images here, and the batch size is how many batch I can train in one iterations. And I can also use the load model here, which can load the previous models saved in the checkpoint, and I just default the load model name as the latest. So if you want to fine-tune this model, just make sure that the fine-tuned model is named as latest. And then I can also create a name here as demo. So this is for where I can save a new model here. So if I create a name demo, I cannot use the load model because there's no models there. Now let me train the model here. Oh, network. Wait a second. So now we can see after a moment we can see there's a image size here, and then print the models here, and after that the results will show in the remote server, and the total parameters can be calculated here. Okay, and so for the wisdom results, the leftmost is the gray input image, and the second column here is the real ground truth, and the third column is for the classification results, and the rightmost column is the regression results. And I also plot the loss plots here, so you can see the plots going down significantly because the data training size is really small. And you can see some results, the faces has already been colored in some mode here. So that's it, and if you are interested in the further detailed informations, please see the reports in the attachment. Thank you.